All right, so what's the LCD here going to be?
15.
And again, that's why I did that first problem that we did where the bottoms were already the same, so we can see why the motivation is to first make them the same. Because then it could just kill them. So what's this? He's a 15 already. Good job. What's he need? 5. What's he need?
15.
The whole thing. He needs
3.
3. Okay. So I'm not leaving anybody out. We've got 4, 15's x minus
10,
15. I like it. 5 over 15 plus
3x over 15.
Now I just have to multiply each thing by 15. And again, I am doing, the rule is whatever you do to one side, you do to the other side, but I'm going to distribute it anyway, so I just kind of cut to the chase and multiply each term by 15. Because I'm going to distribute anyway. Yes?
Yeah, and the reason you can multiply all of them by 15 is because they're all, the fraction is basically just means they're all being divided by 15 right now.
Yeah, and I can multiply both sides of any equation in the universe by 15.
Yeah, but
It's just that some of them it's more useful.
Yeah.
Yeah, yeah.
And this is what simplifies it into just being like whole numbers.
Whole numbers, like kid has. So then the 15s die. This is going to come out nice because, yeah. Plus 10 equals 45 plus 3x. And I like this problem too. If you do it like this, you get used to finding the survivors, right? Who survived. Does that make sense? So later we're going to do other stuff. Yeah, I teach violent mathematics. Part of it is going out in the field and bringing the survivors back in. These guys died. The 4 is alive, and the x is alive. And now I just do it. Minus 3x.
3x.
That kicks a lot of ass because that's just x, and then I just have to add 10. That's really nice. So we're going to do some more stuff, but just to let you know, if you have trouble from this step down, at this stage of the game, you need to really work on that. That needs to become, this step down needs to become a little more immediate, something you can just kind of do. And this is why I like the way the book really focuses on different kind of basic equations to kind of build that up. So you've got to get into chapter 2 homework to get used to the steps of these. When you have a giant, a bigger equation, it looks disgusting, but it's all about what do I have to worry about first? What do I have to worry about next? Don't worry about the whole thing yet.
Sorry to be asking this question, but I didn't know when to stop on the last equation. I actually tried to divide 43 by...
Oh yeah, don't do it. See how it started with fractions?
Yeah.
So end with fractions. Yeah. So let's try one with decimals. Yeah, I got to. And I want to remind you about something I said earlier. Let me see if anybody was listening. What are decimals? So, aren't decimals fractions? Special fractions. They just happen to have 10 or 100 at the bottom. So the way that we handle fractions is the same way we handle decimals because decimals are freaking fractions. What the shit are you talking about, Jen? Well, something like, what if I had this? You don't have to write them as fractions, but what is this as a fraction? 7 over 100, right? 10 6. This will be 45 over 100. This will be 12 over 100. So don't they already have the same denominator? So what am I going to multiply? 100. And what happens when you multiply by 100?
You move the decimal.
The decimal moves twice. So let me show you the ultimate shortcut. Every single one of these, if I move the decimal twice, it would become a whole number. So then I do it everywhere. This is equivalent to multiplying everything by 100. Yes?
So say that 0.45 had an extra digit stacked on the end of it.
Then I have to multiply everything by 3 times.
3 times, and then
I
add the
can't
zero to the end of that.
move him by 2 and him by 3 because then I'm magically multiplying by 2 different numbers at once. Right? I have to multiply by the same thing everywhere. So I am going to multiply everything by 100, but that just translates into this. Right?
Yeah.
Multiply everything by 100, the decimal moves over twice. So then I get, and just to really show you, 0.07x is 7/100ths x, right?
Mm-hmm.
Minus 45/100ths equals 12/100ths x. So then it's exactly like the other problems you were doing. The great thing about decimals are they're always based on 10, so making an LCD is easy. So this is not bad, right? So 7x. Oh, this comes in easy. Look at that shit. I wish I could say that I did that on purpose. But I can't. I think that's right. Hopefully. Yeah. Did I do that right? Yeah. That's right.
I'm saying yes, but that's because it's me, so I wouldn't trust that.
Oh,
I forgot what 9 times 3 is.
all I need is one other person to agree with me, and then I feel better.
I could do that for a job, homie.
No, I don't need a yes man. I just need a So if you really thought about it and agree with me, I'm okay with that. I'm not like, president of the country. Did you just say that? So here's another last example for the day, and then we'll head out. Oh yeah, this is gross. I like it. So, a couple different ways you could look at this. Who needs to be moved the most to become a whole number?
923.
Yeah, so that means he determines what happens to everybody. Another way to look at this is, who has the most decimal places? He does, right? So how do I make him have the same number of decimal places? I just add, yeah, plus 0.070 equals negative 0.923. Now they have all have the same decimal places, right? In fact, notice what I just did. What is 0.07? 7 over 100. Stay with me. What is 0.070 technically? It would be 70 over 1,000. I really want you guys, it was 7 over 100. This is 923 over 1,000. I made this have the same denominator by adding a 0. I didn't move it, I added a 0. So now it has the same denominator. Maybe. So decimals are fractions. You can see analogy between what they are. But with decimals, you can make it a shortcut. I didn't have to really do that. I just look at the one that needs the most movements and then move everybody that much. So 1, 2, 3. Oh, what happened there? 1, 2, 3. 1, 2, 3. So now I get 1100x. Yeah, buddy. Plus 70 equals negative 923x. See, the trade-off, of course, is much bigger numbers, but no decimals. Do you have to kill the decimals? No. Do you have to kill the fractions? No. You can get your electrons together, get LCD. You can leave the fractions alive. Yes?
So you multiply with 1,000?
Yes, it's basically multiplying by 1,000. Because I have to move it over 3 times. Or they all could be over 1,000, so I multiply by 1,000. The same way I made all of these. Where would the other one go? Oh, earlier, we made them all over 6, for example. You multiply by 6. I like it. You might keep. So to solve this, I would do what? Now notice this. I am going to subtract that. Because all the numbers are together already. You with me? So I am going to make it negative, but oh well, just have to deal with it. What happens there? I'll do this side. Oh, okay. What happens over there?
2,000.
Yes. Yeah, negative 2023. You just add because they're both the same sign. And then
Divide by
divide by negative 2023. Easy. I mean, it looks gross, doesn't it? But there's really not that much to do with it, so. Now here, I could give you, I'll let you use a calculator, make it a decimal, because officially if it starts as a decimal, this should sort of stop as a decimal, but I would tell you round it to this place or whatever. I wouldn't give you this problem on a part that I didn't let you use a calculator. That would just be a little too evil. Give me a few more years, maybe I'll be that evil. Dealing with these kids. What do I do with these kids? You're all adults. Huh? We'll call it back South Park. You can't. You will use a calculator in this class, just not always. Because you got me as a teacher. Sorry, you chose poorly. All right. If anybody needs to see me coming up. I need to get a parade of
Bye, Spencer.